Hi everyone, let's do a quick problem here. Other problem no. This problem is related to like basketball game. So on basketball like so any player at a given distance, if he throw a ball at a specific angle, so what must be the initial speed? So that case we will consider some uh, uh, equations and solve them, and we will find also what is needed in a given question. Actually, let me read the problem to you here. So the problem says a 2-meter tall basketball player is standing on the floor 10 meters from the basket, as in the figure below, of course, here as you see down there. If he shot the ball at 40-degree angle with the horizontal, at what initial speed must he throw the basketball so that it goes through the hoop without striking the backboard? Of course, here the height of the basket is the basketball is the basket is 3.05 meter. So as you see here እዚህ ጋር የተሰጠን throw የሚያደርገው let's say here of course this basketball player or Jordan or some kind of player, who knows. So as he throws the ball here, the ball has initial velocity with certain magnitude, but we don't know here. What is given here is certain information ምንድነው 10 ሜትር ከባስኬትቦሉ ይርቃል የምታዩት ርቀት ማለት ነው። ሌላ ልክ የባስኬቱ ርቀት ከመሬት ወይም ከግራውንድ ያለው ርቀት here the 3.05 meter. So we take this thing as just motion into dimension. So motion into dimension በምንወስድበት ጊዜ ያው ፕሪፈረንስ እናደርገው ፍሬም ይኖረናል። So let's take የተወረወረበትን መጀመሪያ ኢኒሻል y initial እንበለውና which is the initial point at which the ball is thrown, and መጨረሻ ላይ ደግሞ ባስኬቱ ላይ የምትገባበት ርቀት y final ነው። So this is y final ማለት ነው። So if everything is just here is given, now the question is finding the initial velocity. So ምንድነው ይሄ ፕሮብለም ላይ it's just totally devoid of time የሚለው ነገር እዚህ ላይ ኮንሲደር የምናደርገው አይደለም። So based on this given information, let's just review some of the equations that govern the projectile motion like this. So one of the thing is the vertical displacement equivalent to what? The initial velocity along the y direction times time minus half gravitational acceleration times t squared. So in fact the initial velocity in this case would be the vertical component of this angle. So here consider that our angle theta is 40 degrees, so the initial velocity here should be expressed in terms of initial velocity and angle theta. So you could write this way: this is the initial sine of theta times t minus half g t squared. That's good. And then what we go on the next, what we'll do on the next step is just simply find expressions that's independent of time and express it the time as some variable from this given information. Now here we have given the range or horizontal displacement. Let's say this is the delta x. Now the time should be expressed the delta x, the initial velocity along the x direction. So let's take this equation 1. Another equation what we need to substitute is delta x as always is v initial along the x direction times t, which is to say v initial cosine of theta times t. Look here, time could be expressed in terms of v initial and delta x. So it is t equivalent to delta x cosine of theta. Take this is equation 2. Now it's easy to substitute this one, equation 1 to equation 2. Equation 2 to equation 1. Now substituting, you would get this expression. Of course you know that this is delta y equals v initial sine of theta and delta x cosine of theta minus half g times t squared, where t squared is in fact delta x divided by cos theta the whole squared. Now a little by simple arithmetic simplification, you would get that this one thing is sine theta over cos theta, you'd get tan theta, and the whole stuff will give you this way. So delta y, the equation that govern this such kind of motion would be like this: delta x tan of theta minus half g delta x squared over cos squared of theta. In fact, don't forget here squared over cos squared of theta. In fact, don't forget here we have initial velocity. So here initial velocity and initial velocity. Of course here the initial velocity, because that's where we're going to find it. So now here everything is given. Now we know delta x, which is the displacement of the basketball, the vertical displacement, which is 3.05 meter minus 2 meter, and that would be a simple substitution from there. So if you rearrange those equations, you could simplify it this way. So the initial velocity could be squared is equivalent to under radical of g delta x squared divided by 2 delta x tan of theta minus here minus delta y cos square of theta. No way, here we have not a square thing. No, the initial velocity, in fact, you would get this expression delta x over cosine of theta under radical of g over 2 delta x tan of theta minus delta y. Now everything is given. Take for instance here g is 9.8 meters per second squared, delta y is simply y final minus y initial, which is to say 3.05 meter minus 2 meter, which is 1.05 meter, and delta x, in fact delta x is 10 meter, which is the horizontal displacement, and theta is 40 degree, and it would be እዚህ በኋላ የካልኩሌተሩ ስራ ይሆናል ማለት ነው። So if you give it for scientific calculator, in fact according to my calculation I have get this one, which is 10.7 meters per second ማለት ነው. So a player should throw with this speed so that the ball will just make it through the basket, and then that's enough.